So hello everyone, once again I welcome you, and it is really inspiring to get you here in this particular session, and we are discussing about data science. I'll be helping you out to walk through this presentation. My speed will be little fast because these are very basics and fundamental concepts, and if you have any queries you can raise your hand, or you can ask at the end, or you can type in the chat and send it to me. So whatever way you feel comfortable, you can keep on asking, because I love to hear questions from the participants. So you can keep on asking whatever questions you have anytime during the session. So we are starting now, data science. If you can interact, that will be really great. So all up to you, like how would you like to basically take up this session? I'm all good with that way. Okay. And are you all comfortable with English? How do you want me to be? Like English, Hindi, or all English? So whatever way you would like to. Okay, okay. So I got a thumbs up that you all are. Yes, Yogesh says, okay, great. Thank you. English is fine. Great. Okay. So chaliye, let's start now. So data science, the whole journey of this presentation will be something like this. We'll start with data. We'll try to understand big data, data science, data mining, artificial intelligence, machine learning, supervised learning. And under machine learning, we have so many approaches. So we'll try to discuss all these things. Initially, things are very simple and easy to understand. And as soon as you go ahead, things become little more interesting and they go into very much depth. Okay, so that is how it happens. So what is data? This is something we have studied in very much basics, like when we were, I believe, in fifth standard or eighth standard. So during that time, we had a discussion on data, or for the first time, we must have came across this particular term, that is data. So data is raw facts and figures. This was the first definition which we had seen, that raw facts and figures. It could be that sun rises in the east. So this is a fact, universal fact. Or sugar is sweet. Or basically, today we had sales of 20,000. So these are some figures. Okay. Last month we had a sales of altogether 20 lakhs. So these are some facts and figures. Or rain, we are actually measuring the rainfall happening in the city of Pune. So all these things, if you see, these are examples of data, and they are facts and figures. So that is something is data which we have read about, discussed about. But if we move ahead, we process this particular data, it becomes information. And this information is having more meaning than just data. So this was the very initial and basic definition which we had very much early initially in the in the journey of computers itself. Okay, I'll not say data science journey, but in the journey of computers itself. Then moving ahead, the kind of data which we see. So the kind of data which we see, we experience these days, it can be in the video format, audio format, text data. This data can also come from different devices, and these devices could be some machines where some interaction is happening. Okay, so these machines where interactions are happening, for example, I'm sitting at home and I want to control my office. Some let's say there's a lab where some experiments are going on. I need to handle some equipments in the lab. Can I do that today? The answer is yes, I can do that today. How can I do that? Because of Internet of Things, because things are connected to each other. If I am using some application which can send this particular message to my office lab, I'll be able to do that. So that is basically called as Internet of Things. And with the help of IoT and with the help of cloud and some sort of like if you see that some sort of messaging systems, I'll be able to pass my message. And that particular, like when I pass the message, that particular message goes via internet to the devices. This is what actually happens. Okay, so once again, I would like to get a confirmation. Are you getting my voice properly? Is there any issue or something? Just confirm me on that before we move further. You're getting my voice properly, right? Okay, no issue. That's great. Thanks for the confirmation. Okay, great.
रात्री पाहिलेलं का ग तुम्ही?
You can mute yourself. आपकी आवाज आ रही है. Okay. Okay, thank you. So, yeah, let us talk about big data now, because this is something again very popular, and everybody talks about it. So data becomes big data. There is a case when data, when basically we start calling data as big data. I always try to give an example. Let's say you're sitting in a room and the room capacity is of let's say around 4 to 5 people can sit in that particular room. So 4 to 5 people can sit. So if 4 people enter, they can comfortably sit. But if let's say we are 8 people, so we may try to adjust all of them in the same room. But if we are 18 people, 1 8, so it will really be a difficult situation to bring all of them into the same room. So we will say that it's a small room. So now what we are saying, it's a small room, or rather, if you see that the room is same, but the number of people who are now coming into the room, they have increased. So there's a difference. Okay. So rather we can say that it's a big crowd as compared to the kind of room which we have. So two ways of looking at the same situation. Very similar way, companies are having some storage systems infrastructure. So whatever storage infrastructure companies are having, so that storage is limited, and like every day that storage can't be increased or extended. That's not possible, because whenever companies plan for storages, then basically they plan for next 5 years, 10 years, 15 years. That is something companies do. So if the storage is fixed, if the storage is limited, in that particular case, what happens? In that particular case, the infrastructure which is there, that will be there for next 5 years. So in this particular case, if the data is coming more, then companies will face challenge, and this is what actually happened. So there are actually 6 V's which make data as big data. This, like those who are from some other department, like those who are from civil engineering, electrical engineering, mechanical engineering. So you might be looking at, you might have first hand experience to discuss these things. But people who are into IT and computers, or anyhow related to computers, you must know all these things. So you can basically bear for today. It's a kind of revision or recap what's happening for you. So let us talk about all of them one by one. If you will have any query, you can ask me once I'm done with this particular slide. So volume. Volume is basically like I have a CPU, and that CPU is having 1 terabyte of storage. And I keep on getting data, lots of data. It can be some videos data, images data, some document files. So I keep on getting data. Now I'm storing that data into my CPU, which is of 1 terabyte. So after 15 days, I could see that out of that 1 terabyte, 800 GB is already consumed. And I have very few, like 100 something is left out. Okay. And you can understand that computers don't basically use all the whatever storage is there. Some of the storage is used for some temporary storage, some of the storage is used for some log data. So in case of 1 terabyte, I cannot make use of 1 terabyte as a whole. I can use of maybe like 900 GB or 950 GB. Rest of the part will be used for some systems storages. Okay, that is how it happens. So when it is about 800, 900, then now I'm facing issue, because data is coming every day, but now I don't have storage. So if I don't have storage, what will happen? If I don't have storage, in that case, I won't be able to store further data, or I'll have to delete the old data. In both the cases, it is a loss. It is a loss of data, because data is very important today. This is volume, that when the volume of data increases, then basically we face big data situation. So take it this way, that these factors, whenever you are facing any of these factors, then big data situation arises. Okay, that time the big data situation actually gets arised. Okay, then we have next one is variety. Variety basically means different types of data. You know that data can be in the form of Excel file, data can be in the form of a text file, and there is a difference between Excel and text. What is the difference? Like Excel file is more organized in the form of tables, like we have columns and we have rows in case of Excel file. But in case of a text file, we don't have that. In case of a PDF file, we don't have that. So if you see that there is a difference in the format here, okay, in the text file as well as in the PDF file and in the Excel file, there's a difference. Okay, now understand, because of this particular difference, if you see this difference, what is happening here? Here basically we are more comfortable with Excel. If you want to do search operation, you are more comfortable. If you are doing some sort of filtering, or so such operations are easy with the help of what? Excel. But with the help of Notepad, no. If you're a programmer, if you write a code, then you see that a code will run sequentially in case of a notepad. But if it is a Excel, you can use Excel functions and it can randomly jump into any row, any column. So you can see that variety means different types of data. And when we have different types of data in that particular case, you can understand that what is going to happen. In that particular case, some data will be easy for you to process, some data will be difficult for you to process. And therefore, we need to consider this particular part, which is of variety. Now, next part is of velocity. Velocity is actually talking about the speed. Now, how speed matters? Because, if I talk about 1990s, okay, so in 1990s, that time basically the speed, the velocity at which the data gets generated, that was not so high. It was not so high as we see after 1990s. If you see after that, like 92, 93, 2000, so if you see the kind of data which is being growing in those years, so it is very very higher as compared to whatever data growth has happened place earlier. So if enormously data is growing in that particular case, what is going to happen? In that particular case, again, your volume is going to get increased, right? Your volume is going to get increased. If the volume is going to get increased, then again, it is a big data situation. So volume, variety, and velocity, these were the very initial days when data was growing at which make data as big data. So these are the reason. If somebody asks you in the interview that why do we call data as big data or what is big data, so big data is basically big data because of huge volume, because of different varieties, because of the kind of velocity speed we see in the data generation. These are the reasons. So these were initially coined by a company called as Gartner, and later on other companies they added up a lot of other things like veracity, value, variability. I'll explain them also. So veracity actually means the trust in the data, trust in the data. For example, let's say you are working into some manufacturing plant, and your manufacturing plant is having sensors, and the sensor is sending some data. There are 10 sensors, and these 10 sensors they send data to computer. So let's say there are two sensors which got corrupted and they are not sending the real data. They're sending some dummy data, like they're sending some static values. Now tell me, what is this? Is this value correct? But you are not aware of it. And it is difficult to get aware of them, very quickly or very easily. So till the time you become aware, so much of data of those static values has come in. So can we trust on this data? The answer is no. So veracity is all about the trust in the data, like how much trust can you do in the data. Then we have value. Value basically means, for example, if you want to travel to moon and you have the responsibility to basically, calculate all the trajectory paths and do the calculations of the angles and the kind of speed the vehicle should have. So will you not be very much concerned about the preciseness of the values which you will be calculating? Yes, you will be. That is the value. That is the value of the data. If I am talking about a business, so in case of a business, what will happen? In case of a business, value basically means that if I'm doing sales forecasting, so if I'm doing sales forecasting, so that depends on the past data. So past data has got so much of value that we can forecast. Okay, so weather forecasting, sales forecasting. If I want to perform customer segmentation, so that is again the value of the data. So value basically means how much business value the data contains. And we know that data has got great value. If I talk about predictive maintenance, that means before any fault occurs, I will be able to identify what the errors are and I will be able to rectify them. That is predictive maintenance. So that brings the value. Okay, because of the data, I'll be able to do that. Next part is variability. So variability is variable. You know what is variable? It is some sort of change, right? So variability is the kind of analysis you do with the data. So the kind of analysis you can do with the data. Today, you may be able to do some sort of analysis, and the next day, after a few months, you may require some more input data, and the analysis, the kind of analysis you do, that may get updated or modified. Okay, variability basically means the way data is being captured, there is a difference in that. If you understand, you were using Facebook initially, so the kind of data Facebook was handling initially is very much different the kind of data Facebook is handling today. Earlier, like there were no provisions separately for businesses or creators or basically a different kind of emojis. It was simply some sort of post and some sort of images. Those were more famous. But like soon, what happened? A lot of things got integrated. Different types of data is being handled by Facebook, and all that data has got different types of analytics they do. So that is called as variability. So here is a one-liner explanation. I'll read it out for you. Then you can ask me any questions. I'll give you a minute's time. So volume means the amount of data coming from different myriad sources. Variety means the type of data. So broad classes are structured, semi-structured, unstructured. Velocity means the speed at which data is generated. Veracity means the trustworthiness of the data. Value means the business value which basically we can bring out of the data we have collected. Variability means the ways in which the big data can be formatted and can be used, different types. Okay. So if you have any queries or questions, you can ask me, or if you're good, you can send me a thumbs up or something. Okay, quickly. So are we good till this now, till this point? Yeah. Can I get a quick confirmation from you all? Okay, great, great. Thank you. Let's move ahead. And now let us talk about certain tools. Now, if this data is there, then how to basically handle this data? To handle this data, we will require some sort of tools which will help us to handle this data. One of such tools is databases. So databases, if you see, they are very much used for handling structured data which is in the form of rows and columns. So that kind of data we can store in databases. Okay, that is thing. Now, databases are very much useful because they store data in the form of rows and columns, and they are used at the back end of so many applications. Like if you see that you go to college and your faculties, they come up and first of all they go to punching machine and they punch because of the attendance marking. Okay, so how that attendance is being maintained at the back end, we have a database. If you see that this Zoom is basically helping us to conduct this meeting, and all of you have logged in into Zoom and then you are attending this particular meeting. So Zoom is actually has captured your in time, your out time. So all that thing we get after after this particular session, we get the whole report. So what sort of data is that? It is also structured data, or I can say semi-structured. If it is CSV file, then we call it as semi-structured. So CSV file, Excel file, so all these are basically in the form of rows and columns, so they can easily be stored and maintained by databases. Databases are used for real-time transactions. So that this is one tool which is used for storage purpose. This is an analogy that like we have cupboards, lockers where we keep some physical files, because earlier if you see everything was being maintained by physical files only. So they were also a place where we were storing our data, but that was completely physical. But now we are storing our data into databases. Like here you can see this is a table and how data is stored into a particular table. So it is organized collection of data. Now there are two very important terms. One term is OLTP and another term is OLAP. So these are very important terms. Many interviewers, they ask about it. If you are giving an interview of business intelligence, business analytics, data analyst, data engineering. So all these, so this is a fundamental question. Okay, this is not very complex or critical question, fundamental question. So if you see that the OLTP, that is online transaction processing, this is for example, if I make a transaction, I use, let's say, Google Pay and I transfer some amount to you. So transferring some amount to you, that basically means that I'm doing online transaction processing because it's a transaction. Then second case, if I'm making an order into Amazon. So making an order in Amazon, what does that mean? So order into Amazon, that basically means that I'm doing a transaction, and that transaction is helping to make some changes in the database. And let's say I ordered a book and there were 10 quantities of the book, and now I ordered, so how many will be there? There'll be only 9. So transaction basically means that either a transaction will happen as a whole or nothing is going to happen. Okay, so transactions are like that. Either a transaction is going to happen as a whole or nothing is going to happen. That is transaction. Okay, either your order is going to placed or your order is not going to place. Okay, if you are making a payment, either the payment is going to get happen or nothing is going to happen. Like it won't happen that your account got debited and the other account did not get credited. This never happens actually. Okay, sometimes what happens, sometimes the money goes on hold with the payment gateway. Okay, but money is there. Like it's not like money got vanished. No, it never happens. So sometimes there is a delay because of the some intermediate body is there in between. That is payment gateway. It may be Paytm, it may be Razorpay, it may be like Amazon Pay, anything like whatever payment gateway is there. So online transaction processing is all about real time transactions, like maintaining attendance, processing the salaries, making some orders, booking some tickets, reservations. All those are examples of transaction processing. But analytical processing means what? Let's say Zomato sends you a happy news that we are offering you a free dinner today. Okay, we will send you. Why? Because you were among top 10 users who ordered the most frequent in a most frequent manner. Now, how did they come to know that you ordered in a most frequent manner? Because they captured all your past data, and then they saw that you were one of those people who are very frequent, like every day 2 3 orders, every day 2 3 orders you were doing. So that is how they analyzed the past data, and they came to a conclusion that yes, you are amongst them who are very frequent in making orders. That is basically called as analytical processing. So understand, like both of them uses SQL, so structured query languages be used in both of them for the transaction, that is real time data processing also, and for analytical processing also. For both of them, what is the language? SQL, structured query language. So this is the fundamental question which is asked in many of the interviews to explain either OLAP or OLTP, and also to differentiate them, that what is the difference between them. So that is a question which is being asked. Let us move ahead and come to a part of data science now. So if I talk about data science, so here two terms are there, data and science. We have talked a lot about data, that raw facts and figures and processed information becomes data. Then we have spoken about that we are not only just talking about that, we are talking about different types of formats, which is structured, semi-structured, and unstructured. So we have spoken about that also. A lot we have spoken about data. Now let us just have a look at science. If you see that the term science basically means that you study a particular subject, explore, observe, experiment. Okay, so science is basically exploration, experimentation, doing research, discovering something, inventing something. That is science. So now, if I am trying to observe the fan is rotating. So when the fan is rotating, what is happening? When the fan is rotating at that particular time, it is trying to blow the air, like it is trying to like throw the air or blow the air towards the like downwards, and that is what the fan is doing. So what kind of phenomena is it? So it is a physical phenomena. Okay, physical phenomena. So we call this branch as physics or physical science, we can call it as. Similar way, I look at water, I look at curd. So if I look at water and I try to understand that what is the chemical composition, it is H2O. So what kind of science is it? It is science of chemicals, science of chemistry, chemical compounds. Okay. So you can see that it depends on a subject. It depends on a subject. If I'm studying some creatures, it may be called as biology or biological sciences or biotechnology. So science is basically depending upon a particular subject. Which subject are you discussing? So here you are very much clear that what subject we are discussing. We are discussing subject of data science. So whatever happens with data, let's say we do data migration, that is data science. We explore some data sets, that is data science. Then we visualize the data, that is data science. We use databases to store and manage the data science, that is a part of data science. So everything you do with data is a part of data science. So this you need to remember, that everything and anything you do with data, it is a part of data science. That is a part of data science. Okay, that is something you should understand. Now let us move ahead. Moving ahead now, here's a technical definition of data science. So data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems. You can see multiple words here. What is the word? Scientific methods, processes, algorithms. That means it includes so many things. Okay, scientific methods. So that means some researcher is doing some research and he's using some methods into that, and those methods are basically becoming successful. He developed a process, and that process is helping him out to perform some research. So if he is able to do this, then in that particular case, what we will call that particular scientific method, that particular process, or if you are sitting and you are writing one algorithm to move from one city to another city in shortest time. So you develop that algorithm. Okay, if you are able to develop such an algorithm, that is again an algorithm of data science. Why? Because you are taking some input. You're taking some input. Maybe you are taking the input of what sort of transportation you are going to take, and what kind of roads do we have, what is the kind of traffic do we face, and how many times the toll tax and all those things would come. So you are considering so many inputs. And what are these inputs? These inputs are nothing but data only. So whenever you are writing some algorithms and they are related to data, then again it's a part of data science. Systems like we have Hadoop framework, we have Apache Spark framework, we have cloud frameworks, and cloud has got so many tool sets there. So they are systems, they are developed systems which help us to manage data and further process data. So data science, if you see, it is multidisciplinary. Multidisciplinary means what? Can we require data science in healthcare? The answer is yes. Do we require data science in manufacturing? The answer is yes. Do we require data science in education? The answer is yes. Do we require data science in case of sports? The answer is yes. Like whatever domain, whatever discipline you talk about, do we require data science there? The answer is yes, actually. If you see that even for sports, now the smart clothes have come, they capture each and every detail of the movements of the player. So that is again part of data science. Okay, so data science is multidisciplinary. Whatever discipline you talk about, it is being used there, and it uses scientific methods, processes, algorithms, and systems. And what is the objective? The objective is to extract knowledge and insights from structured and unstructured data. The what is important here? To extract knowledge and insights from structured and unstructured data. That is the main objective. Another definition I have here is, it is a field of study that combines the domain expertise, programming skills, and knowledge of maths and statistics. So, certain more things, domain expertise. So, in the previous definition, we were talking about multidisciplinary. So, if you want to become a data scientist, you should have a knowledge of a particular domain. So therefore, if you see that people are making a lot of transitions into data science, like whether they are from a civil background, whether they are from mechanical background, even from chemistry, chemical background. So I have seen people are making migrations to data science, and the number is great. Why? Because they also require domain expertise also, right? So if you are expert into chemical sciences, that is your domain expertise. If you are expert into civil engineering concepts, that is your domain expertise. So people require domain expertise if you want to become a data scientist. Programming skills, so yes, that is required because you need to work with certain tools. So at least Python you require, or R programming you require. So people have got first preference as Python or R programming. Then knowledge of maths and statistics. So that is an additional thing that will always help you to make relation between the data if you know maths and statistics. So to extract meaningful insights from the data. So these are the two definitions which help us out to understand what exactly data science is. Are we clear with the concept of data science? Can I get a quick thumbs up or hands up for the same? Are we good with this definition? If you have questions, you can ask me. Okay, I got one thumbs up. Okay, what about others? Are we good? Okay, so one in chat, I got a response. Okay, all clear. Great. So this is very basics. I understand this is fundamentals. I do understand. So let us move ahead and try to now create a whole of the flow that what comes inside what. So data science is like an umbrella term. Okay, what does umbrella term means? Umbrella means that if a lot of other things comes inside the umbrella. Okay, so umbrella terms means a lot of other things come under the umbrella. For example, if you look at the rooftop, okay, so then like under your roof there's fan, and there are windows, there are other things like chairs or the bed or the almirah or the table. So a lot of things are there under the roof. Okay, so similar way, a lot of things comes inside data science. Okay, so that we will understand, and we'll also try to understand, are we doing something which is very new and exciting? So the answer for this is, you can guess the answer. The answer is no. You can see that 1763, from that period only, all these things are happening. Like 1763, Thomas Bayes came up with Bayes theorem. 1805, Adrian Mary Legendre Carl Friedrich Gauss, they came up with regression analysis. Then 1936, that was the dawn of computer age, and Alan Turing, he came up with Turing machine, and the famous Turing test. You know that a computer is kept, a human is kept inside a room, and you are asked to interact with them. If you are able to understand that what is computer and what is human, then the Turing test fails. If you are not able to guess, then the Turing test passes. So such things like making machine intelligence, so such things are basically being done. 1936, then 1943, neural network. So neural network are a lot being discussed these days, but the origin is from 1943. So this is just a glimpse of history, that whatever we are discussing is not something which is happening today. It is something which has been happening from past long time. Okay. Now under data science, we have a term called as data mining. Mining means discovering something, patterns. Very important term here, which is called as discovering patterns. Very important thing. Okay. So think about, let's say you look at somebody and immediately, like a new person, what kind of thoughts come to your mind? Like you went to a session and you were able to meet a new person there. So what sort of thoughts will come into your mind within a fraction of seconds? Okay, it won't happen that the mind is blank. Okay, no, certain thoughts will come. Okay, the thoughts would be, he looks nice. I think he's a nice guy. I think he is also studious. I think he can help me. Or the other thoughts, I think he's not a very techie guy. So I don't think he would be a much help if I take him in my team. So like just by looking at a person, we are able to get such thoughts. Okay, what is the meaning of this? This basically means that we have some patterns developed in the mind. Okay, already some patterns about human beings. And as soon as we look at a new human being, those patterns basically help us to make a group. Okay, group of goods and bads, group of friend and non-friend. Okay, that kind of thing happens. That kind of thing happens. Okay, so data mining is basically a process which comes under data science, and if you see that, it is very much parallel to data science. Like it talks about machine learning, statistics, database systems. So what data science talks about, even data mining talks about that. So here you should understand, mining was very much being used term from a long history, but data science is much newer term as compared to the kind of popularity this data science is getting. So it is much newer as compared to data mining. So they are actually lying at the same level. Okay, so they're actually lying at the same level. Okay. Now, data science can have a lot of activities, starting from collecting the data and pre-processing the data, visualizing the data. So all those things. Data mining may not have all those things, like initial process of collecting, gathering. Okay, so it will just have data and it will start mining it. Okay, so certain more operations will come under data science, which will not come under data mining. So that is a thin line, or there is a very minor difference between them. But if we go ahead and try to understand, let's say you are cleaning your room. Okay, but you said, yeah, every day if I clean my room, it consumes a lot of time, why not to automate it? So what you did, you basically bought an automatic vacuum cleaner, and you started up that, and then what happened, it is basically working on the floor, and it is able to clean up the things. But now, if you have put a piece of dust which is very much new to the vacuum cleaner, so will it be able to do that? The answer is no. Okay. So the vacuum cleaner here is very much smart and intelligent, no doubt, because there is some sort of pattern which is given to the vacuum cleaner, and because of that pattern, vacuum cleaner is able to understand that what is dust and what is not dust, and it is able to clean the dust. Okay, so this concept is called as artificial intelligence, when basically whatever humans can do, similar activities, if a machine is also able to do, we call it as artificial intelligence. Okay, so John McCarthy, so this particular guy, he basically came up with this particular term. But before that, before he came up with this term, there were so many other terms: thinking machines, artificial intelligence, information processing. So there were so many other things, other terminologies for the same domain where people were working. So this guy basically invited many people into Dartmouth summer research project on artificial intelligence to discuss a lot of things, and that particular discussion brought this particular name, that is artificial intelligence, as a standard name to be used whatever is being worked in this particular domain. So that is how this word was coined. Then we have basically, so definition of artificial intelligence, if you see that a machine which can have human intelligence, which can see, like I'm looking outside and I'm able to see a tree, I'm able to see a pillar. So if a machine is also able to identify a tree as tree, and if a machine is also able to identify a pillar as pillar, so that is basically called as artificial intelligence. Okay. So intelligence, humans have got intelligence, and if machine is also able to do that thing, if I'm speaking over here and next time you meet me in the market, and when I'm interacting with you, you don't know that you are meeting me, but with the help of my voice you are able to recognize that yes, he's Kushal only. That is again intelligence. If a machine is also able to do the same thing, that is called as intelligence. Humans make decisions. We make decisions whether to go to college or not, whether to go for a movie or not, whether to eat or not. We make decisions. So decision making is also an intelligent activity. So it's simple. Like the intelligent activities which humans can do, if a machine can also do the same thing, we call the machine as artificial intelligence, artificially intelligent, right? Another definition I have is a branch of computer science that deals with simulation of intelligent behavior. Simulation of intelligent behavior. Okay. So that is, or mimicking or imitating humans. Now, tell me, humans are emotional or humans are logical? What do you think? Are humans logical or humans emotional? How are humans? A quick response? Okay, great. Yeah. So humans are both actually. That's true. So humans are emotional as well as humans are logical. So humans are both. So that means intelligence actually require both the things. So a simple, if I want to summarize, then a machine which can think humanly, act humanly, a machine which can think logically and act logically. So that is an artificial intelligence product of AI. That machine is a product of AI. If you put your tiffin box and your plate and whatever spoons and everything crockery into washing machine, is it a logical thing? So as a human it is not logical, but if you see that for a machine will just try to wash them out, but that will actually that is not a good action. So here if you see that machines have limited intelligence, are you getting this part? Machines have got limited intelligence. The vacuum cleaner cannot go upstairs and or go to the corners of your ceilings and try to do the cleaning over there. It cannot do that. You'll have to either get a blower, or you'll have to get some, again, like some other device which is long enough to reach there and do the same thing for you. So that means the machines which we have today, they are specialized in some particular activity. Like we have robotic arms in medical domain. Those robotic arms do a lot of operations which may incur human errors. Like if you do them with, if the doctor is doing them with hands, that may incur a lot of human errors. So those machines are really a great help. I do agree. Okay, they are a great help. But they are just doing that. You cannot ask the robotic arm to come to the kitchen and prepare a coffee for you. You can't do that, right? So machines, if you see, they are specialized in a particular domain, and they are very much good for that. They're very much good for that. So we need to understand that AI is limited to a particular domain, but that is artificial intelligence. But now my washing machine was not able to recognize that I have put my plates and tiffins into it. That is basically a kind of Dumbo thing my washing machine did. But it's not Dumbo. It's basically lack of learning. If my washing machine can learn that I'm putting some steel items into it, or some metal items into it, or some plastic material into it, and my machine can tell me, oh dear, don't put this, I don't basically serve you for anything except the clothes. So if a machine is smart enough to tell this, or if a machine is smart enough to develop itself to wash the plates and tiffins also, okay, so that's very advanced thing I'm talking about. But if the machine is able to do that, that is basically a component of learning. So artificial intelligence is a branch of data mining, where basically, if you see, in case of data mining, we have so many logics, algorithms, maths involved. And when you are automating that logic, when you are automating that mathematical operation, that is basically artificial intelligence. Let's say you have a path finding algorithm. That algorithm is a data mining algorithm. But if you automate that algorithm and a device is able to find the path, that is a product of AI. So AI is a branch of, is a subset of artificial intelligence only. And your devices are becoming smarter. Okay, in case of data mining, it may not happen that everything happens with devices. You yourself may formulate the algorithm. Okay, so the difference is data mining is broader, and the more specialized term we have is artificial intelligence. Then after artificial intelligence, if you go ahead, then you will be able to understand that the next thing which we have is machine learning. Okay, because artificial intelligent product may not be having the learning ability. So that is also an important part, that the machine should have the learning ability. Okay, if your machine is able to find the path, but let's say you changed certain things. Okay, you have changed the obstacles, and you have changed the way the machine should travel. Now what will happen? The new path, if it is not able to identify, or you have introduced some sort of heights and all in between, and your machine is not able to now identify that. Okay, that means learning is not there. Machine is intelligent to perform the similar operations, but there is no learning for new inputs. That is again, a required, very much important area. So artificial intelligence has got a special branch which specially works on the learning ability of the devices, and it is called as machine learning. Now understand, on top what we have, on top we have data science. Under data science, what we have data mining. Data mining, if you are automating the mining logics and algorithms, what is happening? You are basically creating if you understand that you are creating AI based device applications, and when you have AI based applications, then you are imparting learning ability, that is called as machine learning. So this is the whole hierarchy we are creating, that is called as machine learning. So machine learning is the ability of learning ability given to a machine, and it doesn't require much of human intervention. Like, we don't again and again go back and tell to the machine, okay, do this, do that, you have to do this. Okay, we don't do that. It is machine's ability. Machine does it that way. Okay. So there is a person, Arthur Samuel, who basically came up or coined this particular term of machine learning in 1959. He says that it is a field of study that gives computers ability to learn without being explicitly programmed. That is what is called as machine learning by Arthur Samuel. Other definition is, it is an application of artificial intelligence that provides systems the ability to automatically learn. So you can see the focus is being given on learn, learn, and learn. Other focus is without explicitly programmed, like human intervention is not required. So when I was going through these concepts for the very initial time, initially, then I was also getting mesmerized that how is it possible? How the machine can learn itself? So basically, we need to design algorithms. We need to design the whole program, and that program should be able to do these activities. Okay. So there's a contribution of human beings there. Human being design the whole of the algorithm and program, and that algorithm is having the capability to learn automatically once designed. Okay, so that is how we do it. So we will discuss more about it. We will be going through. Now, our special domain inside machine learning is called as, what is the special domain inside machine learning? It is called as deep learning. Okay, you guys can pinch yourself. Okay, nothing will happen. Okay, but if somebody will come suddenly from the back and pinch you, okay, what will happen? There'll be a reflex action. Immediately, you will, your hands will give a reflex action, and this reflex action is what? This is basically happening because of the neurons which are there in the body, the neural cells. Okay, so these neural cells are quick enough to find a solution to emergency situations. Okay, so if you see that neurons also have got a capability to find solutions, so why not to use the mechanism of neurons? So we tried to imitate the neurons, and that came up with the concept of artificial neural network. And this artificial neural network is the domain of deep learning. We call it as deep learning. So it is a subset of machine learning only. Now, do you understand the hierarchy? The first is data science, then we have data mining, then we have artificial intelligence, then machine learning, and then deep learning. This is the hierarchy which is there. Because many times people ask, is data science same as machine learning? So it's very much simple. Like, many people say they are different and all. No, they're not at all different. They're not different. If you see that in data science we solve a problem. What is what? Okay, let's say if there is a ball, so we train a machine. Can a machine identify a ball as ball and a bat as bat? Can it identify? So this is a problem of what is what. If I talk about machine learning, this problem is This is supervised learning. Earlier, we have experience of balls, small ball, large ball. We have experience of that. So looking at that particular experience, if whatever kind of ball comes in front of us, we will actually tell that this is also a ball. Why? Because we have experience of past data. So this is supervised approach of learning. So it comes in a machine learning. So the way we state a problem, okay, may differ in data science and in machine learning, but they're same thing. If I say water, if I say pani, if I say neer, if I say tanni, so all of these things are same thing, right? So all of these things basically represent water only. So very similar way, the problems which we solve with data science, they are very much same as the problems which we solve in machine learning also. Okay, so if somebody says, are they same or are they different? So we can say, yes, they are having a lot of overlapping things. Overlapping things. Okay, a lot of overlapping things. And simply machine learning becomes a complete subset of data science. This is what is the meaning. Okay, so that's it. Today I'll discuss. I'll be discussing more about different types in the coming session, and then we'll start with the Tableau. You can encourage your friends to join in this particular session. You can keep on giving us the feedbacks and all. If you basically find because if you find any kind of quality issues or something, you can keep on telling us, informing us about that. So from tomorrow, we'll be starting up with the Tableau part, and that is very easy and very much interesting tool. And very much non-technical people from HR, from sales, from accounts, from finance, everyone uses Tableau. Okay, very interesting tool. So we'll be starting up that from tomorrow. Any questions? Anything you have today from this particular session? You can ask now. You can ask me now. I can help you to answer those questions.
Everyday sessions would be at 7 a.m. to 8 a.m.
Yeah, there'll be 7 to 8 every day, 7 to 8. The Tableau session 7 to 8, and there's another session which is of communications. That communication session is for absolute beginners. So those people who are absolute beginners, they can attend those sessions. Then does Tableau require coding? Tableau doesn't require coding. Tableau is very simple, drag and drop. You need some options. In deep, when we go into Tableau, then we have some simple formulas, mathematical expressions we write. Okay, that is something we do. Otherwise, it doesn't require coding. Any other questions do we have? All right. So thank you very much for joining in today. Encourage your
The
friends. Yeah.
other session of communication, that is of this basic concepts, or it is the regular communication skills?
They're just communication skills. Like here, we are not giving any language training actually, but in technology also, or in any kind of interviews or in any kind of discussions, communication plays an important role, and that's why we introduced that. That how can somebody communicate? So it will have different audience. It may not have just people like you. So when you are coming to that session, so you need to be open that that may have people. We are not talking about language here, as I said. Like I'm not talking about just so yeah, English would be discussed. I understand that, but I'm not talking about a language. I'm just talking about communication. That how we should listen, how we should respond to a particular situation, how we should write something. So it's about communication. The language majorly would be English. I agree to that, and if people are not able to understand, then yes, we will switch the language to make them understand. Like it may be anything, Hindi, Marathi, whatever the crowd is, we will try to communicate in that particular way.
Okay, thank you.
Okay, great. Does it cover interview preparation? So yes, we have another section which will be introduced to you maybe in few days, where we have mock interview series going on. So that's a practice mock interview series depending upon the candidate levels. It goes from very fundamentals and to very much technical in depth. Are you going to teach? Yes, Power BI we do that. So already Power BI sessions are going on, but they are in the mid. so you guys cannot attend it. So when they will repeat, so each session gets repeated after some time. So we have a process. We keep on sending that form. You must have seen. You can nominate yourself for that particular training, and you can attend that. Once the training is done, you will be getting a few tests. Okay, sometimes the test would be practicals, some and many a times test will be simple MCQ based, which you will get in the groups and classrooms. You will get added soon, and then basically you can fill up those, because we would require you to fill up all the assessments in order to certify you at the end. Okay, so whatever assessments are happening, you need to attend them. So we'll keep on telling you, informing you about the assessments, so that you don't, if you miss something, then you can attempt it in the next whenever the next time it is being happening. Okay.
Do we have any kind of certification after completion of the program?
Exactly, we have, that's what I said, like you need to complete all the assessments. It would be MCQ based, and a few times it will be on practical, like on live Zoom we'll connect, and you'll have to perform certain practical things. You'll have to interact with the mentors, and then those assessments also you'll have to finish, and after that you will get the certification.
Thank you.
All right, great. Thanks a lot, everyone. Let's meet tomorrow, 7 a.m. in the morning.